Okay, so I guess we're going to get started now. Welcome to the last day of reInvent. I hope you guys were enjoying it. I know I did. My name's Lauren Siegel, and I'm going to be talking about writing JavaScript applications with the AWS SDK. So JavaScript is everywhere. It's in our browsers. It's been in our browsers for almost as long as browsers have existed. If you're writing a web app, you're probably writing JavaScript almost every day. And with things like with environments like Node.js, we're starting to see JavaScript not only used in the client side, but also being moved into the server side. So with a language as ubiquitous as JavaScript, we definitely think it's important to be an important part of the AWS ecosystem. So last year, we launched a developer preview of the AWS SDK for Node.js. And I think we added a lot of features over the last year, and we built a really strong foundation for our JavaScript SDK. We have full service parity, which means we support all features of all services in the AWS SDK for Node.js. And we're continuing to add features at higher level features and nice features like response pagination and waiters. That brings us to today. So a couple weeks ago, we announced the AWS SDK for JavaScript that now works in your browser or mobile devices. And we're really excited about the potential that this new SDK brings for developing web apps right inside your web browser, deploying right to S3 or whatever static site you host, and being able to talk directly to the AWS services. So enough talking about them. Let's actually see what they're like. I have a couple goals in this talk. The first one is to introduce the AWS SDK for Node.js. After we learn about the fundamentals of how the SDK works, I'll talk about the SDK for JavaScript in the browser and some of the differences between the two. And finally, we'll see how you can actually write a two-tiered web application using nothing but JavaScript, HTML, and CSS with the new SDK. So I'm going to start with the AWS SDK for Node.js and give you a little bit of overview about the actual SDK. We have full service coverage, which means we support over 30 AWS services. There's a broad spectrum of services that you can use in the SDK. We have extensible clients, which means you can customize, you can really dig deep and customize a large part of how your requests get routed through to services. So if you need to customize things, there's a really good event-based architecture that I'm going to talk about. We also use standard Node.js idioms, which means if you're using streams, event emitters, domains, we support all of those things. And most importantly to me, it's completely open source and available on GitHub. You can go to the GitHub repo. You can submit pull requests. You can make feature suggestions. You can report issues. We love to get all of those things. So let's get started with the AWS SDK for Node.js. The first step is to install the SDK, and that's pretty easy with npm. All you have to do is npm install AWS SDK. Once you've finished installing it and it's loaded up, you can load up Node and just require the SDK using a standard module require. So you've installed and loaded the SDK. Now you just need to, now you want to start using it. You need to do a little bit of configuration before you can use it, and that's done through the aws.config object. And you mostly just need to configure credentials and your region to use the SDK. You can also configure some extras, and we'll talk about how that works. So configuring credentials, basically, there's a couple ways you can configure credentials. The first one is you can use IAM roles for EC2 instances. If you're using EC2 already to host your application, this is the best way to set up your application. You can also use environment variables if you are not using EC2 or have some other requirements. And finally, you can store your credentials in the file system, preferably outside of source control. And that's because you should not hard code your credentials. Unless So there is one scenario where you will hard-code credentials. I'll talk about this when we do our demo. And if you do hard-code your credentials, make sure that you have read-only credentials and they're scoped with a policy to specific resources so that you make sure that people don't access things that they shouldn't. So like I said, if you're using IAM roles for EC2 instances, all of this stuff is free. It's basically a zero configuration setup. You don't have to do any configuration when you load your when you load the SDK on the EC2 instance. If you're using environment variables, these are some of the environment variables you can use to set up the SDK. That's the access key at the top. You can get the secret access key, and you can also set the region as well. So configuring other stuff, if you're going to do it programmatically, this is how you can configure the SDK. You basically call aws.config.update, or you can just set the config object. It's a standard hash. It's a standard object. And so you can add in the region. You can add in max retry count. The default is 3. You can add in a logger, which will show you some of the requests that go through. And you can check the documentation for more options to set. So you can also configure from a file, a JSON file, if you want to configure, if you have your settings inside of a file. You can use that method to load them into your SDK. Keep in mind that if you're loading credentials through this JSON object, that you should probably keep them out of source control as well. So you've configured the SDK and you want to use it. Let's talk about how you can work with services. So the SDK comes bundled with a bunch of service objects, and they're effectively classes that you can use. So things like AWS.S3, AWS.EC2, DynamoDB, SQS, SNS, and more. To construct a service object, you basically just do new AWS.EC2, and you can pass in optional configuration. If you pass in optional configuration, that will be specific to the service object that you've constructed, and it will inherit the global configuration from the AWS.config object. You can call an operation once you have that service object. You just do ec2.describe instances with this optional parameters and an optional callback if you want to be notified when the request is complete. The callback itself is a standard node error data callback. So error first, data after. If the error is null, it won't. If there's no error, it will be null. If you have data, the data will be in the data. So if you don't use the callback form, you can also just get a request object. And this gets a request object that hasn't been sent. And you could just pass in parameters, and now you have this request object. I'm going to talk a little bit about how the request object works, because it enables a lot of more of the advanced features that you can use in the SDK if you use the request object itself. You can send the request object by just calling the send, and you can pass a callback here as well. You can also add listeners to the request object, and this is our eventing system that I'll talk about. Something like on complete, and you will have a callback that gets fired on complete. So the SDK is made up of requests and responses, and this is a fundamental architecture in the SDK, and I'll talk a little bit about how that works. Basically, you send an AWS request, you get an AWS response. To go a little more deeply into how it works, we have a request lifecycle. And basically what happens is you have an operation, you call an operation, and it returns to you AWS.request object. You can send the request object to, send it off to the server. This effectively starts our event lifecycle when we start emitting events throughout the process. So we will emit event when we build the request. We will emit event when we send it. And we will emit events when we complete it. If you did pass a callback through, this is at the other end right there is when the callback will actually get triggered, and that returns an AWS.response object. So the AWS.request object has a couple of properties on it. We looked at send, and we looked at the on event. It also has things like the .http request object. So if you want to investigate some of the low-level HTTP details of your request, let's say you sent a request and you got an error and you want to figure out if the parameter actually got sent through, you can investigate the HTTP request object and see what the headers we set up or what the parameters we sent through are. There's also more in the documentation if you look at the AWS request object in the docs. So similarly, response has a bunch of properties on it. There's fewer on this one. Mostly the ones you are going to be interested in are the .error property and the .data property, and those are the error and data properties that get passed in the callback. We also have things like the retry count if you're interested in how many times a request was retried before it succeeded. There's also similarly the low-level HTTP response property that you can dig through what the server actually sent back. And again, there's more you can look at in the documentation. So to recap, you send an AWS request, you get we emit some lifecycle events, and we call back with the AWS response. So that's how the request architecture works. It's important to go over this just because we're going to look at some of the features of the SDK now. And a lot of these features rely on this request response architecture. So some of the SDK features that we have that we've added over the last year and I think are really excited. The global configuration object we just talked about. There's also bound parameters, which allow you to send a parameter on each operation that you call for a service object. We'll look at that in a second. We have response pagination, event listeners, API version locking, and secure credential management. So I'm going to jump into, rather than talk about all these things, because talking is boring, let's just actually load up a terminal and start coding. So I have a terminal here. And let's fire up Node to just get inside. And the first thing we're going to need to do is require the SDK. So let's require the SDK. So now we need to configure, what we would typically do is we would configure a region. I've exported my region to my environment on my desktop, on my development desktop here, or laptop. So I have my environment set up, and I also have my credentials in my configuration here. Before we go any further, I just want to set up a logger here. This is going to help us see what's going in and out of our requests. So we're going to just set it to process.standardout. You can set it to anything that accepts write or print. And so now let's just create an S3 object, and so new AWS.S3. So we have an S3 object, and let's send a simple list buckets request to the server. So response equals s3.list buckets, and we'll send it. I could use the callback here, but since we're going to be waiting for this to come back, it's easier in the REPL just to do .send, and we'll see what happens. So I'm just going to add null here so it doesn't print a bunch of stuff after. So you'll see eventually this comes back. We got a bunch of buckets, and now we have the response object that we can do response.data to see our data. And we can do response.error. If there is one, there isn't any. But if we wanted, we can check. So that's how you use the SDK at a basic level. Let's look at one of the features I like a lot, which is bound parameters. When you're working with services, you're often sending a lot of the same parameters through. So if you're working with S3 on an object, you're sending the same bucket through every single request. The SDK has a feature called bound parameters that lets you effectively set that parameter on the object itself rather than sending it through every operation. So let's look at how that works. I'm going to create a new S3 object. I'm going to call it S3 bucket. I'm going to do new AWS.S3. And I'm going to bind a parameter here. You pass the params object parameter at the constructor. And I'm going to bind it to a bucket. So I have a bucket. This is the operation I called just so you can see it. So I call that operation. I have an S3 bucket object. And you can think of this S3 bucket sort of like a resource representing the bucket, because I can actually just call list objects, and I don't need to actually pass the bucket anymore. So list objects, I can response.data to get the data. Sorry, I didn't assign it. And then all my objects are there. I can also get objects on that S3 bucket. So get object, and all I have to do is pass a key. I don't have to pass the bucket. So key, let's get key.txt.send. And I can just grab the body and then turn it into a string. It's a buffer by default, and we should get our contents. So that's how you can do bound parameters, and you can bind parameters to any service. And if you have a bound parameter on a service object and it doesn't, and the operation doesn't actually respond to this, to that parameter, it'll basically be ignored. So I can even call list buckets, which is something you wouldn't necessarily call on a bucket resource, but I could still call this operation. So you can still call that operation. So let's look at another feature that I like a lot, which is response pagination. So we just saw bound parameters. Let's look at another feature. Sometimes when you're using services like S3 or DynamoDB, you'll send requests that give you a lot of data in the response, and sometimes they'll split that response up over multiple actual calls, so you'll have to page effectively. The SDK comes with a feature called response pagination that simplifies a lot of that for you and handles all the pagination on your behalf. So let's create a DynamoDB table object. So I'm going to, similarly to the way we created an S3 bucket, I'm going to create a table object that represents a table in my DynamoDB resource here. And I will bind a parameter to our sessions table. Oops. And let us scan over this table. So I have a bunch of data in this table, and let's run a scan operation on this table. And let's limit it by 10 just so we can get a better understanding of how pagination works. And I'll send it. This is going to return one set of the results. So if I look at the response.data, I'll only get 10 items. And this is typically how you would use it in a normal case, but sometimes there's more data to get. So the SDK has, on the response object, the SDK has a method called hasNextPage that I can call. And in this case, it says there are more pages to get. So there are new pages to get. I can call nextPage to actually return a new request object that I can then send. So this is a request object. So let's send this and assign it to our new response object. And this will, if you look at the logger output, you'll see that it's not only sending a limit and a table name, but it's now also sending our exclusive start key. And that is the exclusive start key for the next set of data to actually grab. So if we look at our data, we have the next set of data. I could continue doing this over the set, and we continue getting more data. But you could do this hasNextPage loop on your own. But the SDK also has a helper method that lets you that basically does it for you. So let's look at that. So I'm going to basically count all the pages in this table. And so I'll do this. DynamoDB table.scan limit 10. And so this is the each page method, which is available on the request object. And the each page method basically does this hasNextPage loop on your behalf. So the each page takes an error data callback. So that is going to be filled with each page of results. If I have data, if there are no more pages, data will be null. So we'll check if we have pages here. And I'll log the page. So page. And I'll also log the data.items.length to see how many items we have in each page. So when I send this off, you're going to see a couple of requests come through really quick in the logger, and each time it'll show the page number and the number of items that are in each page. So let's do that. So you can see it running through, and I have about 11 pages there. And so it scanned and ran through all the pages for me. So I really like that feature. I think it's really useful for scanning over large items, large collections of data. So that's response pagination. Let's look at another feature, event listeners. So I talked a little bit about how you can hook events into the SDK. And there are some events that you might want to capture. So rather than using a callback, if you're using the same callback on multiple objects, you can actually just hook up an event to those callbacks. So let's look at how events work. I'm going to go back to our S3 bucket object here, and I'm going to list objects. And I'm not going to send it this time. I'm just going to get the request object. So here we have a request object that represents a request to list objects. It hasn't been sent yet, and before I send it, I'm going to hook up a success event to this. And this is going to give me back my response object. And I'm going to use this event just to log the data that comes through. So log response.data. So we've added that. I'll show you this again. We've added a success event that just logs the data. And now I can go ahead and send my request. And that event should actually print the data over there. So I can hook up events to specific requests, but if you're sending a lot of requests that use the same events, it might be inconvenient to actually hook them up manually to every single event. So the SDK also has a global events object. And this events object is used every time you construct a new service object. We copy in all the events from the global events object the same way we do from configuration. So let's go ahead and attach an event globally. So we'll do the exact same thing that we did before, but this time we'll do it on the global events object. And we will log response.data. And now we've hooked that up. One thing we will have to do, we'll have to recreate the S3 object, because it only happens when you create a new object that the events get pulled in from the global events. So we'll basically just recreate our S3 object. Let's just call it S3. And I will list buckets. And you'll see once I send this request, it will also log, because it has all the, so it automatically logged all the data. I'm going to go ahead and clear out the event, so you can actually just clear out all. So this is a standard event emitter object, so it uses a standard event emitter interface, so I can remove all listeners. And that gets rid of the event. So when we continue this, we're not going to see more logging information. The last feature I want to talk about is credential management. So I talked a bit about how you can manage credentials properly in your application. Let's look at some of the helpers that we added to make that easier. So you can configure credentials by, if you were to hard code this, and again, I don't recommend you do this, but you can configure credentials by setting an access key ID, et cetera, in the credentials property of config. But we also have a helper method called AWS.temporary credentials. And this object fetches temporary credentials from IAM and STS so that you can use temporary credentials that will eventually expire after a short period of time. It's pretty useful to use this because when you use this kind of thing, if your keys do ever get leaked, you will have a much smaller blast radius of damage because those keys will expire quickly and you can automatically expire them. So let's set this. So that set our temporary credentials. That's all we have to do to configure temporary credentials. It's going to seed the temporary credentials with our master credentials, so it uses the master credentials to get temporary credentials. That's all set up for us. We don't have to do that. So now let's use these temporary credentials. Again, because we've configured it globally, we have to recreate our S3 object. So let's create a new S3 object. And we have a new S3 object that has that temporary credential set up. The cool thing about temporary credentials and all the credential helpers that we have is that they run lazily. So they won't actually go and get credentials until you've actually sent out made an operation call. So I'm going to list buckets here, and you're going to see when I send it, it's not only going to call out to S3, it's also going to do a pre-flight request to STS to actually get credentials. So when I run this, you're going to see STS to get session token, and then list buckets from S3. So that's a bunch of features in the SDK that you can use. I'm going to jump back, and we're going to talk about some more fun stuff, specifically the AWS SDK for JavaScript in the browser. So the SDK for JavaScript in the browser is something we've been building up over the last year. We use the foundation of the SDK for Node.js to build up this SDK. We're currently in a developer preview, and we're definitely looking for feedback. So as I pointed out to the GitHub repo earlier, you can go onto the GitHub repository and submit feedback, feature suggestions, issues, documentation fixes, pull requests. To install the SDK, if you're using it in a browser, you just have to use a script tag. Just use script source there. It's also in our guide documentation, so if you go to the guides, it will show you how to set it up. We currently support 5 services. We support Amazon S3, Amazon DynamoDB, SQS, SNS, and STS. We have support for all modern browsers, from IE to Firefox to Opera, Safari, even Android mobile and other mobile browsers. And the coolest part about this is that if you were paying attention just before, if you've been using the Node SDK over the last year, you already know how to use the browser SDK. It's the exact same code base. The only thing that differs is how you configure the SDK. So configuring credentials is a little different because you're not using EC2. And we're also inside of a 2-tier web application. So when you're inside of a 2-tier web application, you don't have anywhere to hide your secret keys. And so you can't just put your secret keys directly in your application. And definitely don't put your secret key in your application. I can't stress that enough. So let's talk a little bit about the difference between 2-tier and traditional architectures, because I think it's important to touch on how JavaScript in the browser is a very different way to develop applications and can be very powerful. So a traditional web application architecture, you have your clients on the left there, and they're talking to your backend. If you're using Node.js, it's probably a Node.js backend, or it could be a Java, Ruby, or something else. And your backend ends up talking to your services, and then gets the response back, and then passes it back to your client. So that's great. But with the 2-tier web application, we can completely get rid of the middle tier and talk directly to the services. So you can talk, your clients now move directly into the browser. All the code is sitting inside your browser, and you talk directly to the services that you want. There are a lot of benefits to this. The first one is you have fewer moving parts, which means there are fewer things that can break, because you don't have a middle tier sitting between your application that can mess up. You just have your code sitting in your client. Because you have fewer moving parts, it also means that there's less code to write, which means you can prototype much quicker. And deploying applications is also much easier. And speaking of deploying, all you have is a static application. You just have static files. So deploying is really as simple as sending stuff up to Amazon S3 or whatever static host you're using, which means you can actually host a fully dynamic application for literally pennies a month. And that's really powerful. So let's talk about some application ideas. There's a lot of really cool things you can do with the SDK, and I think it opens up a completely new way to think about the way we develop web applications. So a couple of things you can do with the SDK: writing forum software so people can communicate with each other over forum. Similarly, a blog commenting service would be pretty easy to do with the SDK. You can write a blogging platform, similarly, that also accepts posts from authors. If you're writing Chrome extensions or Firefox extensions, this is a great way to use the SDK. You can talk directly to DynamoDB to store large amounts of data, or S3 to store files. Similarly, if you're writing WinRT or Metro-style applications, you can write applications that run locally on a desktop computer that talk directly to S3 without having a middle tier. And if you are writing mobile applications, you have the same sort of criteria. You can write almost any mobile application running locally inside of a browser on the client device. So let's jump into a web application that I wrote using the SDK and nothing but HTML, CSS, and JavaScript. I'll be demoing a simple blog application with content stored in DynamoDB and your assets stored in Amazon S3. So I'm going to pop this back open to the demo here. So I wrote a little sample application here, and it's available on GitHub. I'll show you the link here. AWS Labs is our repo for all our cool projects that we write. And you can go to the reInvent 2013 JS blog demo. I'll give you some time to look at that. So I have a bunch of code here, and we'll just do a quick run through of the code just to see what it looks like. This is the skeleton of my application. This is the only HTML I needed to write to make my application work. It has a bunch of UI. It basically just controls the UI, all the HTML that I need. The important part here is at the bottom is where I load the SDK. Let me just bump that up a bit so you can see it better. So this is the part where I actually do the loading of the SDK. And we load our application code. And so we also have a little bit of information about our application, and this is the app.info.js file. And this contains all of our SDK configuration details. So we're going to be using Facebook to actually do OAuth logins, and I'll talk a little bit about how that works in a bit for the admin user. And I mentioned before, not to hard code your credentials. This is a very specifically scoped credential for read-only access to my DynamoDB table and only for my DynamoDB table. So you can embed, so users who are not logged into my blog should still be able to read it. So I have an IAM user set up with read privileges for that database. And I also have the table name there and the region that it's in. And for S3, similarly, we're going to be storing assets there. So I have my S3 bucket that I'm going to be hosting in it. We could do a quick look at the application itself. Most of it is controlling the UI, so that some of it's just standard HTML DOM manipulation. I'll just run through a couple of the actual uses of the SDK. So this is where we will upload assets. And so you could see this operation is s3bucket.putObject over there, right there. And you can see, if you were following along, this is basically exactly what you would do in the Node SDK. So it's very similar to do. We also have a published article. So this is our interaction with DynamoDB. So you can see we use the item up there, and we actually just put item the same way we would if we were using the Node SDK. We also have a delete. And the rest of it's mostly just the UI stuff. Here's a little query. We're doing a very simple query, and we're using response pagination to get each page. We could actually set up paging. It's a very simple blog, but we could set up paging if we wanted to. So it's only a couple hundred lines of code, 260, and it's very simple to do. This is the OAuth login stuff that we'll be talking about in a bit. So I actually haven't even deployed this yet, so we're actually going to deploy this together. So I'm just going to jump into the so just to show you how easy it is to deploy an application, I'm actually using the CLI here. If you were at the CLI talk or if you heard about the CLI, we have a new unified CLI. And I'm using the AWS S3 sync command to actually just publish all of my assets in this directory up to S3 on my bucket. And so let's just call /publish. And you'll see the S3, the CLI is going to upload all of our assets. And we've now just deployed our application. So let's go check S3 to see our application running. Oops. So there's currently nothing in our blog. Let's log in to actually Sorry about that. It's running on HTTPS. So there's nothing in our blog. Let's log in to actually add a post. So I have this set up. I had this registered with a Facebook application to handle my login for me. And this is going to give me permission to actually use my application. Oops. There we go. So you can see that this is some of my, the application enables me to post now because I'm logged in as an admin. And so I could click post. And I could say, let's create a post, say, welcome to reInvent 2013. And let's say, so we're writing a post. I just have this little what you see is what you get editor here that Stack Overflow uses. It's open source. You can use it on yours. It uses Markdown. So we get live preview at the bottom there. And this editor has this way to embed images. By default, I think they just let you link to an image. But I've modified this a little bit to actually let me select an image. And this is actually going to go and upload the image to S3 on my behalf. I've actually set up logging the same way we set up logging in our terminal, so you can actually see a lot of the stuff that is being sent through. So you can see originally we actually had the DynamoDB scan that did the read all the posts and display them to user. And then we did our login operation down here, assume role. And then we finally logged in, and now you can see our put object operation that we actually sent through. And so if I just update, you can see that the post shows the image there, and I can just say, like, hope you are enjoying the sessions. And so let's publish this post. And you can see, if you guys have your laptops opened up, you can actually hit this reinvent blog demo-s3.amazonaws.com. You guys can follow along and actually refresh your page. It should be up there now. So I can actually go in and edit this post. Now that I'm logged in, I can go in and edit. Let's make this a comma, and let's just say so I can edit the post, and it's updated. And again, if I refresh the page, I get the same stuff. I can also add more posts just to see how how it scrolls. So I have my database ordering by date, so it'll automatically show the last one first. And so again, if I refresh, it'll show it. So that's the little demo. I can also delete. Posts. So that's a little blog demo. We're going to jump back and talk a little bit more about some of the features that I just showed here. So what are some key differences between 3-tier and 2-tier? I talked a lot about logging in, and I talked a lot about how to manage credentials. Browser security is very different when you're developing 2-tier applications, specifically when you're dealing with cores and when you're dealing with credentials on devices. So it's really important to understand how it works and how it's different from a 3-tier architecture. So let's talk about cross-origin resource sharing. Cores is effectively this thing that says that basically your browser says, am I allowed to actually send a request across a domain? So typically your browser will not let you send a request across a domain, but cores enables you to opt into that behavior from the host's end. So what happens is your browser sends a pre-flight request to the external host and asks the question, am I allowed to operate on this domain? And the server is supposed to come back and say, yes, you may, or it might say, no, you can't. In that case, you get stopped. But if it says, yes, you may, that's when the browser sends the XHR request. So for S3, S3 has a cores configuration feature. If you've dug through the permissions, you might have seen it. Effectively, what you'll have to do is you'll need to configure cores on S3 in order to use it. the way you configure is you use the bucket policy to actually configure cores. This is a sample, and you might not be able to see this, but if you load up the console and you click the permissions tab and you go to the cores configuration editor, this is what they'll pop up. They have a bunch of samples, so it's actually kind of easy to get started with it. But you'll need to set up this configuration in order to use the SDK with S3. With other services that are authenticated, like DynamoDB, SQS, SNS, you don't need to configure cores. Cores is already on because you have an authenticator request already, so you don't have to worry about that. The issue here is that you have public assets on S3, and you want to make sure that you're sending them to the right people. So cores, that's how you set up cores. Let's talk about credentials. So again, never hard code your credentials. Again, I can't stress that enough. You should not be hard coding credentials in your application. Don't leak secrets. Bad idea. The way that we get around this is we use a feature of IAM and STS called Web Identity Federation. And this is a feature that we released a couple months back that allows you to use Facebook, Google, or login with Amazon as third-party identity providers to do the OAuth login. Effectively, what happens is you register an application with those providers, just like you would with any Facebook developer application. And what you do is your users log into that application as if they were using it, and they get an access token back. And that access token gives them access to that application. But what you will be doing with that access token is you'll take that access token, you'll come to AWS, and you'll trade that access token in for AWS keys. And AWS with Web Identity Federation will actually talk to the application and make sure that the user has the correct permissions to access the application, and then give back keys to your JavaScript application. That way, keys are never actually hard-coded embedded in your application. So to set up Web Identity Federation, what you'll need to do is set up an IAM role for the identity provider. It's pretty easy to do. If you go into your console, in the IAM console, you can create a new role in the Roles tab, and you can click Create New Role. And at the bottom there's a little box for Role for Web Identity Provider Access. You'll click that, and basically it'll give you a drop-down for Facebook, login with Amazon, or Google. And you will give it your application ID that you've registered with those identity providers. After you set up that, you'll be running through the wizard, and we'll ask you to set up permissions. This is the part where you'll set up specific permissions to access only DynamoDB, my specific table, or S3, and you'll make sure that your permissions are correct for that user. Again, make sure that they're only accessing the resources that you want them to access. Once you've set up your role and you have an ARN for it, this is the call that I use in the blog demo to actually get credentials. So we saw the temporary credentials management thing in the demo before to actually just get temporary credentials. This works in a very similar way. You just assign the AWS Web Identity Credentials object to your global credentials, pointing to your role ARN and a provider ID, and finally, the Web Identity Token. The Web Identity Token is the access key that you got from the OAuth procedure. And after you do that, all of the calls that you make will be authenticated through Web Identity Federation. Again, it'll run lazily, so it'll send a pre-flight request to STS to get those credentials, and then come back and make the follow-up request. That's what you saw in the logs before with the assume role with Web Identity. So we talked about how you do it in the SDK. The process of getting the OAuth token will differ per provider you use. This is the example for Facebook. This is a minimal example for Facebook. You can actually go to the identity provider's documentation. They give you pretty good examples on how to get access tokens. But you would basically call fb.login. There's other ways to do it, but here's one of them. You can call fb.login. And if you are successful, the response will be response.auth response.access token. And now you have your FB access token. You can throw that into the Web Identity Credentials object. And now you're ready to go with authenticated access. Again, if you're using Google or login with Amazon, it's basically the same thing. Once you get your access token from those identity providers, you can go ahead and just trade it in for actual access keys. So that's how you would use the JavaScript SDK in the browser and in Node.js to build really cool applications. I want to end the talk by talking about something that I think is really important, and that's our community. So at Amazon, we love open source. All of the SDKs that we release are available on GitHub, and they're all licensed under the open source Apache 2 license. We really believe in a strong community, and we really think that everybody should be involved, and that's why we do get involved in open source. Our project, again, is available on GitHub, right there. We definitely love to get feedback. We definitely love to get pull requests. I said this before, I'm going to stress it again. We love getting contributions to the SDK. So if you run through the documentation and you see that something might be a little awkward, we love to see people helping us improve the docs. We love to see when people report issues. It's how we know we have issues, so please report issues to us. If you see something that you can easily fix, please go ahead and fix it. That would be great. Submit pull requests. And finally, if you're writing something that you think is a little larger and might not belong in the core SDK, or don't really want to necessarily go through the trouble, you can also write a third-party plugin. And third-party plugins are a great way to add features to the SDK. Features that might not necessarily be part of the SDK itself, but like helper methods, high-level abstractions over DynamoDB. If you look at our package on npm.js.org, you can see a list of dependents, and those are all the npm packages that actually use the SDK. And you could look through that list and find things that may help you use S3 more easily, or DynamoDB more easily. There's a couple there in that list that you can look through. Finally, as we move into the browser, Bower is a really cool package manager that we're looking at to see how we can actually get packages for JavaScript in the browser, and see how we can sort of set that up for the community, and how we can be involved in that as well. So we definitely want you guys to write more and help us out and contribute. We continue contributing, and we think it's great to have a really strong community. I think that's really how we're going to drive all this development forward, is having a strong community. So with that, I want to thank you guys for listening to my talk. I'm going to be up here for questions just in a bit at the end here. And we love getting feedback. Like I said, we love getting feedback, so please give feedback to this talk if you enjoyed it, or if you didn't like it, let us know. So thank you.